Hi, this is Jeremy. I'm going to show you how to do the exercises that go along with a Math Antics video, factoring. Are you ready? Here we go. Our first problem says factor 16 in two different ways. Now remember from our video lesson that factoring just means unmultiplying. We have to figure out what we could multiply together in order to get 16. Well, one thing we could do in order to get 16, which you could do with just about any whole number, is you could multiply it by 1. You could say 1 times 16, and those would both be factors of 16. So that's one way to factor 16, but we're not going to use that way because that way is pretty obvious. Any number, any whole number could be factored like that. Instead, we're going to look for two different ways to factor 16. It's not that this is wrong, it's just that this is what's called trivial factors because you can always do that. So instead, we're going to ask ourselves, what can we multiply together to get 16? And if you remember from your multiplication chart, we could get 16 by multiplying together 4 times 4. So that's one way to factor 16. You could say 16 equals 4 times 4. Another way you could get 16 is if you divide it in half, because 16 is an even number. And if you divide 16 in half, you're going to get 8. So 2 times 8, because 2 eighths is 16. So that's another way to factor 16. So two different ways to factor 16 are 4 times 4 or 2 times 8. And problem 2 wants us to factor 30 in two different ways. Again, factoring is just unmultiplying, so we need to ask ourselves, what can we multiply together in order to get 30? Well, 1 times 30, that would work for sure. We know that any whole number could be factored into 1 times itself. But let's see if we can find some other solutions too. Let's see, 30 could also be 3 times 10. 3 tens gives us 30, so 3 and 10 are factors of 30 also. 30 could also be factored as 5 times 6. If you remember your multiplication chart, 5 times 6 would give us 30. And there's one more way. 30 is an even number, so we could divide it by 2. 2 is a factor. 2 15s, or 2 times 15, would also give us 30. So these are all the different ways we could factor 30, and our problem only asked us for 2 of them. So if you picked any 2 of these solutions, 1 times 30, 3 times 10, 5 times 6, or 2 times 15, then you got the answer right. The next problem asks us to factor 40 in 3 different ways. Okay, so we need to unmultiply 40. We need to think of things that we could multiply together in order to get 40. So we could get 40 by multiplying 1 times 40, of course. That will always work, so let's just get that out of the way. 40, we could also get that by multiplying 4 times 10. So 4 and 10 would be factors of 40. That's one way to do it. 40 could also be factored into 5 times 8. Remember our multiplication chart, 5 times 8 gives us 40. And 40 is even, so it could be divided by 2, so 40 could also be factored into 2 times 20. So there's 4 different ways, including the trivial way, 1 times 40. So it only asks us for 3, so let's just choose these 3 ways to factor 40. 4 times 10, 5 times 8, and 2 times 20. The next problem asks, is 7 a factor of 52? Now, one way you can always tell if a number is a factor of another number is to do a test for divisibility. If the number will divide evenly into the bigger number, in other words, if it'll divide without having any remainder, then you know that it is a factor of the bigger number. So let's try that here. Let's take the 52 and let's try to divide 7 into it and see what we come up with. Well, 7 won't divide into 5, so we're going to have to take the whole number. Let's see, the closest multiple of 7 that would go here, 7 times 6 is 42, too small. 7 times 7 is 49. That looks promising. 7 times 7 would give us 49. That's not too big, but you can see that's going to give us a remainder. We have a remainder of 3, and 7 won't divide into 3. So this does have a remainder, so that means that 7 is not a factor of 52. Answer is no. And problem 5 asks, is 3 a factor of 42? Again, if we need to figure out if this is a factor of that, we can just do a test for divisibility. See if 3 divides evenly into 42. So let's set that up here. Here's our 42. And let's try to divide 3 into it and see if it will go in without a remainder. 3 will divide into 4 once. So let's put a 1 up here. 1 times 3 is 3. We subtract and we get a remainder of 1 here. But we have this 2 to bring down. So let's bring down the 2. Now our problem becomes 12 divided by 3. 3 will go into 12 4 times, because 4 times 3 is 12. And that means we're going to have no remainder. So that means that 3 is a factor of 42. You could multiply 3 times 14, and that would give you 42. So yes, 3 is a factor of 42. The next problem asks, is 9 a factor of 153? Okay, these numbers are starting to get big here. I don't remember 153 on the multiplication chart, so this may be a little trickier to figure out. But the process is exactly the same. We can do a test for divisibility. We can say, will 9 divide evenly into 153? So we could write that out just like you would if you were doing a long division problem. Divide 9 into 153 and see if we get a remainder. Or in this problem, you notice you can use your calculator on this because it's a big number. It's fine for us to do that. So let's just try that with our calculator here. Let's take 153 and divide it by 9 and see what we get. We get 17 as our answer. And there's no decimal after that, so it did divide evenly. 9 went into 153 17 times. So yes, 9 is a factor of 153. Our last problem is a little different and a little longer than all the others. It says, find all the factors of 16. So we need to take the number 16 and find everything that could possibly be a factor of 16. That's kind of a process, and the best way to start a problem like this, where you have to find all the factors, is to start making a list of numbers that you want to test. You're going to do test for divisibility on anything that's a possibility for this. So what you do is you start with 1, and you list every number up till half of this number. Half of 16 is 8. So we're going to list 1, 2, 3, 4, 5, 6, 7, and 8. And then we're also going to list the number itself up here, 16. And we're going to check all those numbers. The reason we list 16 is because we know that 16 is a factor of 16, because you could multiply 1 times 16 and you would get 16. So these are always going to be factors. 1 is always going to be a factor, and the number itself, 16, that will be a factor of this too. So we need to start testing all the other numbers now. Let's just do it in order. We ask ourselves, is 2 a factor of 16? Well, since 16 is an even number, it ends in a 6, 2 would be a factor. So we get to circle that. And we can circle another number because 2, we have to multiply that times something in order to get 16. And that number is 8. When we multiply 2 times 8, that would give us 16. So 8's also going to be a factor. Now let's check our next one. 3. Will 3 divide evenly into 16? Well, if you remember your multiplication chart, you'll know that it won't. You could also use a calculator to test that. You could do 16 divided by 3, and you'd see, oh, a huge decimal number. So no, 3 won't divide evenly into 16, so it's not a factor. Next, we'll check 4. Will 4 divide evenly into 16? Yep, if you remember your multiplication chart, 4 times 4 equals 16. So 4 is definitely a factor. Now we can check 5. Will 5 go in evenly? No, because multiples of 5 either end in a 5 or a 0, and 16 ends in a 6. So 5 can't be a multiple, or can't be a factor of 16, because 16 isn't a multiple of 5. Next, we can check 6. Let's do that with our calculator. 16 divided by 6 gives us another crazy long repeating decimal. So that has a remainder. It's definitely not a factor of 16. Now let's try the last one we haven't tried, which is 7. 16 divided by 7 gives us 2.28, blah, blah, blah. Lots of decimals there. So that also didn't divide evenly and is not a factor of 16. So there, now we can make our factor list. All the factors of 16 are 1, 2, 4, 8, and 16. Those are the factors of the number 16.